match any concepts. Today we'll be treating on differentiation from the first principle. Now, as an example, find dy dx for y is equal to x raised to the power 3. Now, for us to do it, there is solution. We're having dy. It's not we should solve for dy dx for y is equal to x raised to the power 3. So y is equal to x raised to the power 3. And what you do now, you increase the x for x and dy for y. That is to say, you're going to add dy to y and add dx to x. So you're having y plus dy is equal to x plus dx raised to the power of 3. Then what you do, you open this bracket. Then you're having x plus dx, x plus dx, and x plus dx. You expand it. So you're having y plus dy is equal to x plus x, x plus x, x plus x. Then you multiply. You use x to multiply everything in x plus x. So you're having x times x is x squared. X times dx is plus x dx. Dx times x is plus x dx. Dx times dx is plus dx squared. Into bracket x plus dx. So this one now we are having two like terms here, which is x plus dx. So this one is x plus dx and x plus dx, they are like terms. So wherever you don't have any number, there is a one beside your x in algebra. So we are having x squared plus dx plus x plus dx will give you 2x dx plus dx squared into bracket x plus dx. Now you use this one now to multiply everything in the brackets. So you're having x squared times x will give us x cubic. X squared times x dx times dx will give us plus x squared dx. 2x dx times x will give us plus 2x squared dx. Now 2x dx times dx will give us plus 2x dx squared. Dx squared times x will give us plus x dx squared. Then plus dx times dx squared times dx will give us dx cubic. So we are having y plus dy is equals to this answer. Then we're going to go to the next one, which is collection of like terms. Now you can add this x squared dx, 2x squared because they are like terms. I can also add 2x dx squared and x dx squared because they are like terms. So we are having y plus dy is equals to x cubic plus x squared dx plus 2x squared dx give us 3x squared dx plus 2x dx squared plus x dx squared give us 3x dx squared, then plus dx cubic. And the next thing you're going to do now is subtract y from both sides, in which your y is equal to x raised to the power 3. So from the left hand side, you say y minus y plus dy is equal to x cubic plus 3x squared dx plus 3x dx squared plus dx cubic minus, open the bracket, x cubic, because your y is x cubic. Then continue now, y minus y is 0, so this one is gone. We are having dy is equal to x cubic plus 3x squared dx plus 3x dx squared plus dx cubic minus x cubic. So x cubic minus x cubic gives you 0. So you're having dy is equal to 3x squared dx plus 3x dx squared plus dx cubic. Now you divide both sides by dx. So over dx all over dx. So you're having dy over dx is equal to, when dx goes in this dx, it will remain 3x squared plus dx goes in dx squared will give you 3x dx because this is dx to the power 2. Then plus plus the s goes in the s cubic, it remains the s squared. Now you limit the s as it tends to 0. That is to say, anywhere you see the x, you put 0. So you have it equals to 3s squared plus 3s, here is 3s dx. So the x changes to what? 0 plus 0 squared. So you have it 3s squared plus 0 which is equals to 3s squared. Therefore, dy dx is equals to 3s squared. Thank you. See you next time.